In this example, we're going to use transformations to sketch the graph of the function g, where g is defined by g of x equals the square root of negative 4x. To do so, we'll identify the original or basic function and explain how the graph of y equals g of x is a transformation of that original function. While we do this, we'll make sure that we state all steps to this transformation in an appropriate order, and in our graph, we'll make sure that we plot 3 key points and that we track them through each step. So to start, let's identify that original function. So we're looking at the square root of negative 4x, so the most obvious choice of those basic functions is that our original function is going to be the square root function. So that'll be defined by f of x equals the square root of x. And then as far as what transformations have happened here, we can see I have this the main form of our transformations above, and we can see that because we have a negative 4 inside that square root, that we're looking here at having a b value of negative 4. So we're multiplying x by negative 4, which means that we're going to see a horizontal stretch or compression, and then we'll also see a reflection. So the first thing that we'll see, because of that negative, we're going to see that this graph is going to reflect across that vertical axis, or in this case the y-axis. So we'll reflect across the y-axis. And if we're wondering why that occurs, we've multiplied all of those input values by negative 1. So all of those x values are going to switch sign. Anything that's negative will become positive, and anything that's positive will become negative for the x values. The second part here is going to come from the fact that we have that 4. So we have that value of b is negative 4. The negative causes one transformation, the 4 causes another. And so looking at a b value of 4, since we've already multiplied this value of x by 4, what we're going to see is a horizontal compression by a factor of 1/4. And anytime we're dealing with a horizontal stretch or compression and we're identifying that value of b, remember that it's always 1 over b. That's the factor by which we stretch or compress. Okay, so to start on this graph, we need to start with the graph of y equals the square root of x. And so if we don't remember exactly what that looks like, we can make a quick table and plot that in. And so I'm going to want points here that are easy to work with. So I'm going to make sure that the x values I choose give me integer values for my outputs. So with a square root function, it would make the most sense to pick perfect squares. So I'll pick 0, 1, 4, and 9. And so the output at 0 will be 0, at 1 it'll be 1, at 4 it'll be 2, and at 9 it'll be 3. So I can plot these points, and I'll have 0, 0, 1, 1, 4, 2, and then 9, 3. And then I'll connect these, and that'll be my original function. Okay, and so for our first step, we're going to reflect across the x-axis. So the point 0, 0 will stay put, but then the point 1, 1 is going to move over to negative 1, 1. The point 4, 2 is going to flip over here to negative 4, 2, and then the point 9, 3 will flip over here to negative 9, 3. And so that's our first step there. Now we can apply that second step. So we have stated here that it's a horizontal compression by a factor of 1/4. And so what that means is that every x value will be multiplied by the factor 1/4. The y values will stay the same. So if we look at these points, we see that this first step here has the point negative 9, 3. So if we're multiplying that x value by 1/4, that'll be negative 9/4. And let me just write that out real quick. So we're taking negative 9 times 1/4, and that'll be negative 9/4, or negative 2.25 if we're thinking of it in decimal. So I'll plot that then. I'll go to about negative 2.25 and 3, so in there. And then negative 4, 2, that one's a little bit easier. That will go to, I'll multiply that x value by 1/4, so that'll go to negative 1, 2. And then negative 1, 1, multiplying that x value by 1/4. I'll be at negative 1/4, 1, and I'll plot that in. And then 0, 0 will again stay put. So it'll be helpful if I label each of these points. So this first point that I had was negative 9/4, comma 3. And then this next one was negative 1, 2. And then the last one that I had was negative 1/4, comma 1. Okay, so now I'm ready to connect to these. There's one other detail that I can add in, and that's that that original function would have had one more value. So it would have had 16, 4. And then when that's reflected across that x-axis, that would have gone to negative 16, 4. So that detail is helpful when I want to sketch a more accurate graph of this, in that the point negative 4, 4 is going to be on here. So I'll put that in and I'll label it. That's not critical, but it'll help me get a more accurate sketch of this graph. Okay, so I'll connect these. And what I have there then is my graph of y equals the square root of negative 4x.